Hello everyone, welcome to my YouTube channel. Today in this session, I will continue this tutorial of Decision Tree, but this time I will show you the implementation of Decision Tree based or using Python languages. Well, as we see here in these cells, we need some package, some library to work with. So we need pandas, we need NumPy, Matplotlib here to in this tutorial. Well, the first step I will do here is to import the Seaborn library. It's a famous one. We use Seaborn here for visualization statistics, but also provide for us function can give us the ability to load in some dataset without trying to import it from some place. In this case, I will work with famous dataset Iris Flowers, one of the famous datasets we have in the world of data science and machine learning. It's like hello world in this field of machine learning. Well, to do that, I create a variable called df, that means data frame, equal to is ns, that means the alias of this package of cborn, dot we load in the dataset, we using this function of load dataset, okay, provided by the cborn uh, load dataset, and they give the name of the dataset we want. So in our case, it's arrays dataset. So after this, I run this dataset here as we see. Well, if I try to import more than five records, so by default we know this function over here gives us the ability to show the five top records. Now I can change that. I will give it maybe 15, for example. And if we run it here, we'll see 15 first record in our dataset. Okay, here. Okay, let's create another cascading div1 equal to div1 here. Hit hit artist. Well, if I run it now. Okay, here I created again here. As we see, we have here one, two, three, four variable or four feature and one target here species. This is the type of dataset we have here. Okay. Well, let me show you again here. Adding a new cell to show you something. Well, if I create an df1 plot spaces, plot, well, if I just choose this species, species, okay, sorry, I want just show you the content of this target. Uh, Now I add in this function of union. Okay, okay, that's great. Well, here as we see, we try to solving this multi-classification problem. Why I tell you do. If I go to this target variable we have here, spaces, if we check in the content or the values we have here, that does mean the not duplicated values. We gonna get uh, feature or three values. We have Cituza, Versicolor, Virginica. Well, what is the call here? If we give for my model some measures here of speed length, speed length, and speed width, model give me the name of or the species based on these four measurement here in this variable. That is the goal. Okay. Well, this is multi-classification. Why? Because we have more than two values here. We have three values. It's not binary, but it's multi-classification problem. Based on this first, or based on this four variable we have here, the measurement, we are making the prediction and see what is type of or the species of this flower we have. Well, if we continue this process, we see here. Well, this the feature engineer I make here is I try to change those values of Citosa, Versicolor, or Virginica, and I give for them some ordered values starting from 0 to 2. That means based on this math function we have here, if we go to these pieces here, I think we show you for now. If we go to these pieces here, we have Citosa, we have Versicolor, and Virginica. So Versicolor and Virginica is not clear here, not show it here because I taking just the first five records, but if I change this by thing, maybe it's not also not well. If I go to using the tail function file, okay, file function now, maybe you can get some. Yeah, we have here Virginica. Okay, because my model cannot understand those string values. It was a versicolor or Virginica. For this reason, we need to change these values and give for them some numerical values. Well, the next step here, because we don't have any transformation to make it here, because all this is ready for prediction, because all these types here is integer. We have just this species. We need to transform it from string to some values. Well, that's what it is now. Well, here, based on the secular package, also famous one, we are importing this tree. As I tell you before, this problem is not classification. For this reason, we need to import decision tree classifier, not regressor, it's classifier. Okay. Well, here in this, the next step here in our problem, we need to instantiate from this decision tree one object. So I call it here in this case classifier equal to decision tree classifier. Criterion is entropy. We discussed before this post pruning. If someone is interested now, what's mean that you should go to the layer or the some two last tutorials of this decision tree to understand deeply what's the mean post and post pruning and per pruning. Well, in this case, what they do now here, I try to fit data independent feature second parameters y dependent because we need to split our data to predict or the dependent feature in this case is species and we have independent feature in this case this fourth variable we have. Okay, so independent variables in this case it's spill length, spill width, petal length, and petal width. the target or dependent variable is spaces. Need to split. Well, that's what we do here in the syntax of Python. We apply this classifier.fit function. That we need to make all these measurement way inside of this function to calculating the variance or the distance between each point here without trying to divide it by the standard deviation. So here df.alloc this function import all the records or all the features without including the last one, that means spaces. And in the second parameter, I use in the same time df.alloc import just the last one, just spaces, the records of last one. But here the records of all the features without last one. Okay. Well, again here for scikit-learn and import just the tree. Well, here what I do, I want to make some visualization. I using this PLT matplotlib. Okay, figure here I give some measurement to make my figure clear. In the second syntax here, we have tree dot plot tree classifier file. It's to, well, what is the idea behind this is to show this tree decision. Well, if I run it, this is what I get here. See some measurement here. Okay, sample of all these, all the sum of the records we have, all the shape of these records is 150, and for column, okay, we have 50 for each type of flowers. Well, so this is the figure. As we see here, the decision tree, as I tell you before, it's made from each else test in programmation language. That means we need to check in the conditions we have. So in this case, we take in h3 and we check the value is also equal to 0.9, 0.8, sorry, and the value of entropy in this case, because here is in post running, I using the criterion of entropy. There is here. That means we have the probability of class positive log this class plus minus here of this class plus the other one, because we have three classes here. We using this log function inside of this formula of entropy. Well, the first value which we get here is 1485 or 1585. The number of simple in this case is 150, as I said before. The value of each type here is 50. You have three types. That means 350, or 15 simple for each of these two. So here is none. This case is none. That means the entropy is 0. So if not, if you remember all, the number of simples is 15, because this one just we found this value of entropy based on this 15 simple, but the other ones don't care it, because we get here the leaf node goes here now. If yes, we go to check in the others or the other values here in this x3. Let's equal to 175. The entropy is 1. Simples is 100, because the 50s go to other side, the left side, and then continue with these 250s. We have 50 for the other one, but for bus color, for example, and the other for. Okay, well, if we continue here, we go again. We check in the x2, so it's equal to 4.95. The entropy in this case is 0.544. The samples is 54. Okay, and the value is here. We have 54. We have, sorry, yeah, 49, and we have 5. On the other hand, we have these values of G2. This position here, we need to see this value inside of the variable, and we need to compare it with this one here. 0.0151. The sample is 46, and we have this value is 141. 45. Entropy here in this case is 0. The sample is 43. This value here, and we go to the left side again, checking those values. We see the entropy, and we go out the end. Well, if you remember the problem we're gonna face in here using this by default max depth, it's overfitting problem. We discussed that before in the last two sessions. We are talking about the overfitting problem, on how we can have this overfitting problem. I tell you before, if we are implementing this model based on the default parameter we have inside this function, at this time we're gonna facing the overfitting. Well, one of the technique or the trick we can use here to avoiding or to minimize or decrease the rate of overfitting our dataset is using this max depth. If we remember, we need to control the max depth of this tree. If we look in here, we have this one until the end, until the final what's called the lift node. Okay, the lift node here because the value of entropy is 0. We left leaf node here, sorry, leaf node here. Okay, and then with the leaf node, that means we cannot extract any more information based on this node. Okay, well, here in the second the model or the second version, in this case I give for this attribute of max depth 2. That means I want just to node. Okay, the max depth here to go behind it is max. Well, I do the same thing here. The criterion is entropy, of course. We have max depth is equal to 2. At this time, I try to fit again this one. We have here dependent. We have here dependent, independent feature. But here we have dependent feature. Well, I run my model. There is the result here. I apply again this PLT-tree to visualize this one. And if we look in here, we have just two as max of features is 2. We have one. We have here in the left side we have entropy 0. That means leaf node. The other hand, we have here these values of entropy is 1. Okay, that means we can continue on this way or this row on this other or this way. We have a lot of information to extraction more in this leaf node or in this node. Sorry. In this case, we divide in these simples into 2. In this case, we need to we have this entropy give us this value 0.4. Simple is 54, and in the right on the right hand, sorry, we have entropy 0.5 14. We have simple is 46. Well, here we have not the overfitting because we give for our classifier the max depth is 2. Okay, as we see here, we have just 2 features. Well, so if we continue here also, because the criterion in the first time I use entropy, as we know, if you remember the curve of max entropy or the entropy, the value we can get here is 1, and which time we can get max 1 or the entropy is equal to 1 if we have 50% of value. That means we have the same value. This time we can found 1 as a value. Here in this example, we're using the Guinea. Okay, Guinea, that means the max value we can get is 0.5. And if you remember, well, we're using the Guinea if we have a huge data set. And we're using the entropy because if we have small data set. Why? Because we need to decrease the complexity of sources and time. We need to decrease the complexity. For this reason, we need to use entropy in small dataset and unique in huge dataset. So in this case, we have the criteria is equal to Guinea. We fit again our dataset, and this is the result. What I get here. If we check in the Guinea, in this case, we have this value is the same, but the Guinea is different. So we go in the list. We have the Guinea equal to 0, and this time it's leaflet. So we cannot continue based on this node. So we go to other side. This means the right side here, and we check have each 3 equal to 175. Gain is 0.5. The max value we can get. But in the entropy we found 1, but here is 0.5. So we still continue here. Okay. Now the same trees, because we're taking that by default, we are not specified the max depth here. Well, if we so it's an observation as I said before, all this value we can have based on the Guinea is between 0 and 0.5. Values between entropy is 0 and 1. This is the difference, the range of values. Well, here I apply the same thing, say creating classifier 1 here. Max depth is 2, and the criterion is Guinea. We supply then our data, and this is what they get if I run my visualization. This is what I get here. Guinea is 0.667. We have simple 150. We have value 15, 15, 15. X3 1 7. Guinea is 0.5. Simple 100, and we still going in this side here. Okay, why we apply this max depth? Because we need to avoid the overfitting. Okay, so here the pre-pruning, we need to dividing our data by using this model selection of twins display. So I creating here this one. We have X train, X test, Y train, Y test. So from scalar we have this model selection, import train display function. We're creating 4 variables here as we see. Equal to train split or train display. We have div of ilog, df of ilog for this independent feature, and for the target one here, and we have size of test is 0.3. That means 70%, or yeah, it's 70% just for training and 30% for testing. Okay, and the random state here is equal to 0 because I need to run it one time. Okay. If I run in the extreme here, this is the values of what I can get here. This is all the values here for extreme. Okay, without species, if we look in here, we don't have this target variable because we supplied in our data. Okay, well, if we go in here again, also we need to mirror our model or the metrics. We see the metrics of our model. Okay, well, from scalar we have metrics. From scalar those metrics import accuracy, score classification, and the reports. We need to import both of these metrics. Well, we have the parameters because this phase is for a per parameter. We cannot know which kind of functions or which kind of values we need inside of these parameters to predict well our value. For this reason, we need to specify some parameters here. The criterion we have both, we have in index. We cannot what is the best one here in both of these based on this other set of processes. Choose a randomly supplier, or we go to choosing the best one. We have max depth. We cannot now watch which the values the model will go well with 1 or 2 or 3 or 4 or 5. Can specify more than those values. Also for max features, it's auto. That means how much of features I need to combine to do this processing. Scared or log to or also I don't know. We basically if I just did few parameters because inside of this decision to reclassify we have much of functions. That means we have a lot of parameters. We can do this using research. Just for winning of time, I avoid to use that, but it's okay to work with. Well, I chosen just a few parameters. Well, the grid search this is the best way give for us what is the best parameters here based on all these parameters I go here. So I give for here. Sorry, we're classifying one equal the decision to reclassify instantiate from this class. Well, we have to see if I give some name for this one here. Yes, the resource is equal to grid search. Okay, grid search classifier one. I give for I instantiate from this class. The parameters. This is the parameters I chosen just. Scoring is accuracy. Okay, and I need to divide in my dataset for 5 times each time. So the idea behind this research is I divide my data for 5 parts. One part for 4 parts for prediction and one for measurement. That means I divided my data set 4 times. Each time I predict and I measure accuracy and I try to find the best accuracy. Well, if I run, this is the parameters I have here. Okay. Well, I apply this function of base parameters here. What does mean? What is the base parameter in this side of this parameters? Oh, you have the criteria is Gini. Then we have the Gini. That means here based on that we have Gini and max depth is 5. Okay, it's 5. That means if I want to avoiding the overfitting, I need to using as a max depth 5. Max feature it's auto and splitter is the best. It's not random. So if I make these predictions, wide train predicts is fit to predict extreme, and here extrace predicts is fit to predict extreme. I make now prediction based on this one here, based on these parameters of my model. Well, if I go to measure the accuracy, for train score called accuracy score, wide train, wide train predicted. I need to compare between train and train predicted, and score is 99%. It's perfect. Well, if I go also for this one for white test predicted here for twin, here for test, we have 097. Okay, we have this one is perfect based on this data set. Well, if we go to measure the parameters, this is what how the classification report. White is predicted, yeah, white is predicted and white is, and this is the report of classification because I have three classes. Well, we're talking about precision recall and if one score. This is all the result I get here. If we look in all these measures, it's perfect. That means my model is ready for okay. So I hope that's clear for you all. Just in this session, I not to go deeply uh, in this model. But just I show you how we can use in this tree decision because personally I consider it one of the amazing algorithms we have, especially some technique backend and testing. Well, we need to have an idea about how algorithms work. Well, I will post this link here in description. Okay, and share it what other each one is interested to know. how decision tree is works. Well, happy learning for anyone. See you again in the next tutorial. Bye bye. See you again.